Hello everyone, we are glad to present our research entitled Advanced Modular Housing Design, funded by Department of Housing and Urban Development, HUD. The project is a collaborative research between the Fiber Lab, Powell Center, ERPSIS Lab, and Schimberg Center at the University of Florida. Mahia Sam and I, Maria Khuirostami, are going to present this research. Hope you enjoy it. Global warming has become the biggest threat to the entire humanity. The possible damage of climate change on construction is becoming more tangible to the construction industry, I can say, over these past years. Hurricanes, earthquakes, tsunamis, surges, and even fires are frequently destroying our communities. Hurricanes are perhaps the major natural disaster that occurs in the United States, especially in the southeast area, such as I can say Florida, and they frequently cause enormous destruction, including the leveling of communities. This project, Advanced Modular Housing Design, addressed the enormous challenge of rapidly rebuilding communities that have been damaged and even perhaps destroyed by major storms. This problem will likely become even more challenging due to the increasingly powerful and more frequent hurricanes that are forecast to strike the US and particularly, I can say, coastal regions. In this presentation, we will start with a short background of major US hurricanes and government reaction to post-disaster communities. And also we are going to present some case studies as our literature review section. Then we will present the research goals, and at the end we are going to focus on the affordability aspect of our design. I'm going to start with a definition of what is modular or manufactured homes. Manufactured housing is a type of prefabricated construction that is assembled in factories and then transferred to the site. This type of house is built to meet the code and regulations of US Department of Housing and Urban Development, HUD. The term modular home is sometimes used instead of manufactured home, but it's not the same. However, the term represents a different type of house. Modular homes are constructed off-site in a factory and shipped in a wide variety of layouts and designs to the homeowner's lot, where it is assembled and installed on a permanent foundation, as would be the case for a traditional home. Choosing modular homes instead of site-built homes has various advantages, such as a shorter period of construction, I can say a safer workplace for the laborers, higher quality and productivity, and at the end, lower cost, which is very important for our community right now.
Hurricanes include all tropical cyclones which have produced sustained winds of greater than 74 miles per hour. This study would focus on the southeast areas of the US, which are considered as Zone 1, 2, and 3, based on ASHRAE Climate Zone map. Regarding literature review, after all disasters, hurricanes, the government and the industry provide some essential proceedings to enhance the catastrophic situation. Hence, this part of the study includes 3 sections. First, the history and damages of major hurricanes, which their landfalls are America's Climate Zone 1, 2, and 3. Secondly, the government reactions, mainly the Federal Emergency Management Agency, FEMA, which is responsible for disasters, are mentioned. The third part belongs to the industry and private companies' responses. Since 1851, 298 Atlantic tropical cyclones have produced hurricane-force winds in every state bordering the Atlantic Ocean and Gulf of Mexico, and Florida was affected more than any other state. List of Florida hurricanes encompassed approximately 500 tropical or subtropical cyclones. More storms hit Florida than any other U.S. state, most notably Hurricanes Andrew, Irma, and Michael in the 1992, 2017, and 2018 seasons. The 1990s were the most active decade for the United States, with a total of 31 hurricanes affecting the nation. By contrast, the least active decades were the 1816 and 1970s, each with a total of only 15 hurricanes affecting the country. The Federal Emergency Management Agency, FEMA, is an agency of the United States Department of Homeland Security, which was founded in 1979. The mission of FEMA is helping people before, during, and after disasters. After each hurricane, FEMA and local officials work to bring RV or trailers, but these temporary shelters are available only for 18 months. Also, survivors of hurricanes can live in temporary housing units, which are provided by FEMA. Indeed, FEMA allocates financial assistance to homeowners for repairs or replacement of their wind-battered houses. The agency also provides temporary housing, hotel rooms, and short-term condo rentals. Overall, based on this research, the government primarily supplied temporary housing and mobile units after hurricanes. There was no significant evidence of successful efforts for rapid provision of permanent housing. Tornadoes, cyclones, and other storms with strong winds damage or destroy many buildings. However, with proper design and construction, destruction by these factors can be greatly reduced. A variety of methods can help a building survive strong winds and storm surge. As discussed above, government response does not generally include rapid permanent housing. The priority for housing victims of disaster is most often placement in temporary shelters. Financial assistance for short-term habitation and guidelines for builders and homeowners are also regularly provided. However, many private companies design hurricane-resistant homes of various size and price. Prefabrication tends to involve faster and more efficient construction process, offering promising alternatives to traditional stick-built homes. Those structures have been designed to withstand strong winds and, in a few cases, Category 5 disasters.
The next step is analyzing some similar case studies to find out how they could answer the problem. And the first one is a prefabricated house in Melbourne's City Square. Modular buildings specialist Archie Blocks has unveiled its prototype for a compact carbon positive house featuring edible garden walls, a sunroom, and an insulating grass roof. This project has been selected because of hyper-efficiency, energy design, and also the material selection and size of the project, and also because it has been designed very well. It can be used as not just a temporary answer, we can use it as a permanent answer. The second one is Quinta Monroy Elemental. This project addressed the community resilience problem after a major disaster. And this project provides a sufficient response to the land use problem. And you can see in the picture that it has the opportunity for users to expand it and develop their house over the years. And the last one is prefabricated modular home by MAPA. The structure was entirely prefabricated before being delivered to its rural location, which is potential. But MAPA says the buildings can also be transported in pieces and assembled on site. Starting from a mini mod invests in customization, design, and sustainability of the project. This building has been selected to consider the transportation problem and its potential. And here I want to talk about our research goal. Our project, or the home that we want to design, is going to be a hyper-efficient and energy self-sufficient. The home is able to cope with future severe weather events, and it's going to provide basic services needed for families during post-disaster recovery. Also, it is rapidly built in factories and can become a major community asset. This research has been conducted in the context of three key challenges facing the US housing industry, as we all know: resilience, sustainability, and affordability of homes. Here in this presentation, we are going to focus more on affordability section of our research. At the first point, we'll start with evaluating demographics of manufactured and modular home buyers. More than 22 million Americans live in the approximately 8.5 million manufactured homes scattered around the country. Manufactured housing is disproportionately located in non-metropolitan areas, and approximately 32% of new manufactured homes are placed in a community. A greater proportion of households that live in manufactured housing is headed by a retiree, which is 32%, and compared to 24% for site-built households. Data shows approximately 80% of households are 62 years of age or older. However, in some states, such as Florida, which manufactured homes are more common, this percentage goes up to over 40%. Manufactured homes can be precast or customized based on what we mentioned before, with numerous floor plans, configurations, and sizes. Hence, based on the size and quality of the manufactured homes, the price may change. However, the average sale price of a manufactured home in 2019 was around $81,000. Again, in 2019, manufactured homes accounted for around 70% of all new single-family homes worth less than $125,000. According to a study by the Manufactured Housing Institute, it can cost, I need to say, manufactured homes can cost 20 to 30% less to build than an equivalent conventional home. For comparing off-site construction costs and on-site construction costs, we came up with a process. First, finding proper application, then finding estimation method, after that gathering design information, and at the end calculation. Also, for our just estimation process, we started with converting on-site costs to off-site costs, selecting estimation software, test the software, then gathering information again from design, and at the end calculation. Literature reviews show that there are two methods to convert, I can say, on-site construction costs to off-site construction costs. First one is, for material, we need to have 10% reduction And on labor costs, we need to consider 30 to 40% reduction to have the off-site construction costs. The second method is, again, 10% reduction on material and 1/3 of labor costs in on-site construction. Finally, we chose to use 10% material reduction and 34% reduction on labor costs based on our interview with industry experts about their experience in the factories. This slide is a very short version of our final estimation, which based on very high quality material selection and hyper efficient energy design. We could came up with around $110,000 for a 1,200 square footage building. We used RSMeans software to gather the price information of each material.
We consider three processes for the life cycle economics. First, energy efficiency upgrades, including major energy efficiency measurements. Second, simulating building energy optimization. And third, life cycle cost analysis. This is the process of life cycle analysis. For initial construction costs, we consider building materials, building equipment, labor in the model. Then we mention a simple payback period, which is the time required to recover the project investment without considering the time valued of money. And finally, to calculating life cycle costs over a 60-year period, we adopted initial costs from RSMeans cost data, maintenance and replacement costs from RSMeans facilities maintenance and repair cost data, and utility costs from BIOP energy modeling. For example, calculating replacement cost of an item, we consider these details based on RSMeans to come up the right price. Here you can see how changing one of the energy efficiency measurements can change the total cost of the project and also the annual energy consumption of the building. Here is the example of changing the exterior wall insulation from R11 to R21 to save more energy.
We approach this research by incorporating cutting-edge technologies into developing advanced modular housing design. The Advanced Modular Housing Design research addressed the design of housing that can ultimately be rapidly built in factories, that can cope with future major events, as we mentioned before, and that can become a community asset. In summary, I can say that the solution we propose for addressing the problem of how to rapidly provide large quantities of post-disaster housing is advanced technologies and process improvements that support the design and manufacturing of resilient, sustainable, and affordable post-disaster housing. It is an ongoing project, and the final result would be released by December 2021 to HUD. Thank you so much for listening us and have a very nice time.